In this example, we are going to solve a problem when the reactants and product are initially present in the container. So we have 2 moles of A gas in equilibrium with 1 moles of B gas and 1 moles of C gas. At 900 degrees Celsius, the Kc is 1.4 times 10 to the power of minus 2 if 2 moles of A and 1 moles each of B and C are introduced in a 1 liter container at this temperature. What are the concentration of A, B and C at equilibrium? So since we have the Kc value here, we are going to use the reaction tables in concentration terms. So we have the initial concentration, the change in concentration, and also the concentration at equilibrium. Okay, so since we have the number of moles and also the volume, okay, so we know that concentration is equals to moles over volume in liter. So since the volume is 1, okay, so 2 over 1, we have 2.0 molar for A, for B 1.0 molar, and C is also 1.0 molar. So if we have the value for each reactants and product at initial, okay, we are going to calculate the QC of this reaction. So remember, the reaction quotient expression is same as the equilibrium constant expression. Okay, but the difference is the value of this concentration is the value of the initial concentration. So substitute the value of the initial concentration into this expression. You will get the value of the QC, which is 0.25. After you got the value of the QC, compare it with the value of the Kc, which one has the higher value. So in this case, Q is bigger than K. Okay, so the value of the QC is bigger than the value of Kc. So since the value of Q is not equals to K, we know that the system is not in equilibrium. Initially, there are more products in the reaction mixture. Thus, to reach equilibrium, the reaction will proceed to the left. So, since the reaction proceeds to the left, the reactants will form and the products will decrease. So, we have 1 moles of B, so B will decrease in X. C is also in decrease in X. Okay, and A, we have 2 stoichiometric coefficient in A, so A will increase into X. So at equilibrium, okay, the concentration of A is 2 molars plus 2X. For B, we have 1 molars minus X. C is also 1 molar minus X. So to find the value of the concentration of A, B, and C at equilibrium, we need to find the value of X. So first, write down the Kc expression. And we already have the value of the Kc, and then substitute the concentration at equilibrium for B, C, and A. And then solve these mathematical problems. We will have a quadratic equation. So rearrange it until you have the quadratic expression, which is this expression. And then from your calculator, okay, press the menu and then take the equation, okay, alpha A, okay, and then take the polynomial equation, okay, and then we have a 2 degree, select 2, and then put the x square value, okay, which is 0.944, okay, press equals, and then for b value, okay, the x value here is negative 2.112, press equals, and then the c value is positive 0.944, and then press equals, okay, press again the equals button, and then we have two value of x, okay, the first one is equals to 1.62, and then the second value of x we have 0.617. Since we have two different value here, okay, try to substitute it into this table. Okay, so we have 1 minus x is, if 1 minus 1.62, you will get a negative value. So since the concentration cannot be in negative value, so we are going to ignore this value. Okay, just ignore this value, and then this one is the value of our x. So substitute the value of x into the concentration at equilibrium, we will get concentration of A is 3.23 molar and concentration of B and C is 0.383 molar. So remember, if the reactants and product are present initially, find the value of Q and then compare it with the value of K. If the reaction proceeds to the right, it means that the product will increases and then the reactants will decreases. But if the reaction proceeds to the left, the reactants will increases and the product will be decreases.